So shift left is about integrating quality practices into every phase of the software development lifecycle. So it's not just about testing at the end, which is traditionally where it happens. And as you can see from the diagram, that's a fairly typical project where there's a load of work done up front, including development or a new piece of software is delivered, and then all the testing is very much at the back end. Shift left is very much about bringing the emphasis for quality and involvement of quality far earlier in that life cycle. Fundamentally, it means moving those quality checks and testing far earlier in the development process. So instead of waiting until the end to find and fix defects, what we want to do is identify and resolve defects as early as possible. And even better, what we want to do is prevent those defects from even happening. And that proactive approach, that proactive strategy helps reduce the overall costs and time to market for programs and projects, and fundamentally ensures a far smoother project flow. You're much more likely to hit your timeframes, far more likely to hit your end date. So not only are we getting QA specialists involved earlier, and it doesn't need an army, it could be one individual that's just getting involved earlier and guiding and supporting the other teams, but we are also promoting that quality is a key component within a project. It's considered from the outset, and it's fundamental to how that project's going to be delivered. So now that's a very high level overview of what shift left is. Now what I want to do is just cover off some of the benefits of adopting that shift left approach and incorporating those quality engineering practices early on. Okay, so the number one benefit is that defect prevention. And by embracing that shift left approach from the start, as I said before, we're not only catching defects early, where they're quicker, cheaper to fix, which obviously saves time and resources, but more importantly, we're looking to prevent those defects from even happening. And what the graph represents is a typical project where we're not going to put all the blame on developers in terms of defect injection, but it's very much going to be how good the requirements are, how good the scope of the project is, etc. That really does drive how good that development's going to be. And because the developers are writing the code, typically that's where the defects first happen. And then it tends to go into that testing, and you can see the orange line is showing us where defects are typically found. And as you go through a project, particularly towards the end of a project and when you go live, the cost of fixing that defect becomes massive, exponentially goes up through the life cycle of a program. And you can easily imagine why, because if you're getting close to live and you find a significant defect, you've basically got to go all the way back to development. You've got to fix that. You've got regression tests to go through. Suddenly timelines are being extended. The cost of resources is going up, and you're getting to the point when you might even make decisions to go live with issues, which is obviously not the position we want to go in. So that red line is really highlighting how expensive defects are as you go through the life cycle. Hence, the benefit about defect prevention is really important. And if we can go to the next slide, please, Adam, we can look at the impact of shift left. Because what shift left is fundamentally doing is it means that by preventing defects even happening, although you're still going to get defects, it means that you're going to you haven't just got the QA team looking to test those and find them. Developers are also doing their best to identify issues while they're going through their code with specialist tools and disciplines. It means that those defects aren't even making out the development life cycle. And overall, the timelines improve, the number of resources isn't as many, and the cost of fixing defects and the cost of the project fundamentally is drastically reduced. Just looking at the next benefit, it's about increased collaboration, because the shift left approach promotes that collaboration across teams, be it BAs, be it developers, be it testers, operations teams. It's about all working together and sharing that responsibility and accountability for quality right from the beginning. And that collaboration fundamentally leads to better communication and fewer misunderstandings. And one of my bugbears is people making assumptions that almost 99% of the time are wrong. It's about reducing those assumptions and ensuring that teams are working collaboratively and working better together. The next benefit is really around increased efficiency and productivity. When you have early quality checks, you streamline the whole development process because the developers are geared up for quality. They're building quality into their code. They're coding defensively. They're ensuring that security is already there. They're ensuring performance is built into the code. They're, all those good disciplines that developers can learn, but can also be backed up with some really great tools that can help developers as well. And the final big benefit is really around cost savings. So by very obviously by detecting defects early and preventing defects, it means that the projects aren't suffering from issues far later on. The development process is far better streamlined. The testing is going to be easily planned and usually on time, because really what testing can then focus on is just around integration and working with business users to ensure it meets their requirements. So we got some four significant benefits there, and a short thought, what we've done is we've taken all the experience of the projects we've worked on, and particularly implementing quality engineering and shift left practices, and we built a framework that incorporates those shift left disciplines to help organizations access and improve their QE practices. So if we have a quick look at the model, I won't go through it in detail, but fundamentally what we've got is we've got 5 maturity levels, starting at foundational QA and going through to continuous quality. And organizations will be at depending on the organization you're at, they'll be at various levels on that maturity scale. Foundational QA is really just the very basic testing. That's usually you've got a very immature test team, if at all. You might just have users testing, and it's about really just finding defects as best you can. Most companies tend to be an integrated QA, so you've got a QA team and they're very much working with other teams to do testing properly and with a strategy. But when you get to the shift left, number 3, that's when the benefits really start kicking in, because then that's about preventing defects from happening. And then what we talk about is when you integrate QA within an organization, QE becomes very much holistic. It becomes part of what, everyone's accountable for quality at that point, not just one team, everyone's responsible. And then level 5, it's really about just ensuring you've got that continuous quality in place within an organization. And that's when the quality is really part of the DNA of that company. And I'm sure we all can think of some companies, the obvious examples are Apple, for example, where quality is just ingrained in everything they do, right from the design through build, through everything. And the end client can feel that quality when they pick up an iPhone or whatever it might be. And basically what we've got is underpinning those maturity levels. We've got 6 key QE maturity drivers that there's a whole set of tangible actions, steps, templates, methods that we have within those drivers that lift the maturity of an organization so that they can go up those maturity levels. And the benefits can be significant. One of our clients has seen a 40% improvement in their product quality, 25% reduction in the time to market, all through following this maturity model. So just to wrap up, involving the right people up front through the lens of quality engineering and shift left is crucial for a project success. And as I say, it doesn't need to be an army. It's just about making sure that you've got the right people that understand quality involved from the very inception. And that QE maturity journey that I've just been through, that really does help organizations achieve that sustained success by progressively enhancing their quality practices. And at that point, I'll leave it there. Thank you, Adam.